Hi there, Serdar Yagulop here for InfoWorld at IDG. Today I'm going to demonstrate Python's cProfile module used to generate runtime performance profiles of Python programs. Previously we talked about the timeIt function and how that can be used to time the performance of small snippets of code like individual functions. cProfile, also included with Python, profiles the behavior of applications in whole or in part. cProfile runs an existing Python program and generates an analysis of all the function calls made in the program, how many of each one, how long they take, and whether they're calls made to native Python functions or to calls to other functions in the application. The results are then saved to a binary file, which you could then use to generate a human-readable analysis. For this example, I'll analyze the runtime behavior of a program I wrote for an earlier video in this series, a version of Conway's Game of Life. I wrote two versions of that program, a fast one and a slow one. I'll start by analyzing the slow one, and then show how the analyses gained from that could be used to generate the fast one. Working with cProfile is a three-stage process. First, you take the application you want to analyze and set it up to run with cProfile. Then you take the profile generated by the app and produce a human-readable report from it. Finally, you use the report to figure out where your application's bottlenecks are and make any improvements. For the first step, you can use cProfile from the command line, but it's often more flexible to run it from within the program you want to analyze. In this example, I'm just wrapping the program's main function, its entry point, with cProfile. cProfile.run will run the function supplied to it and then generate its trace information based on everything that happens in that function. Since that function is our program's entry point, we're in effect tracing the whole program's behavior. The results of the trace are written to a file named output.dat. The next lines we see here use the pstats library, which goes hand in hand with cProfile. pstats is used to take the results of a cProfile run, saved here to output.dat, and generate human-readable reports from it. We're creating two reports with pstats, the first being the total number of time each function takes, and the second being the total number of calls made per function. Now let's run the program for a few seconds and generate some results. As you can see, we now have the report files in our program directory. The first, outputcalls.txt, lists which functions were called the most. Let's take a moment to look at the format of the output. The ncalls column is the total number of calls for the function in question. The next two, toTime and perCall, indicate the total time spent inside the function call and the average amount of time spent for each call. The next two, cumTime and perCall, indicate the total time spent inside the function and all other calls made by that function, and the average time per call for that as well. So what we want to pay most attention to in this report is the functions that are not only called most often, but that spend the most time internally. Those are most worth optimizing. If there are function calls we can minimize or optimize out entirely, that'll speed things up, especially if those calls are being made in tight loops. The topmost item in the list, shown in curly braces, is a Python built-in method, appending to a list. That shouldn't surprise us, since appending to lists is something a lot of Python programs do quite often. Below that, though, are calls to the random number function generators in Python's standard library. We generate a lot of random numbers in this program, so we make a lot of those calls. However, keep in mind how total numbers of calls without context can be misleading. For instance, in this case, all the calls to the random number functions are performed at program startup, and at no time after that. Optimizing random number generation won't speed up the main body of the program at all. I'll return to this issue later and show you how to avoid gathering misleading statistics. Now let's look at the second report, outputTime.txt. It has the same multi-column format and the same values in each column, but here it's being sorted by total time spent in the function. That's the most useful statistic to have for this particular program because we can now zoom in on which functions are the slowest overall. Here, it's the generation and render functions. Their per call times are agonizingly slow, so those would be the best places to start optimizing. I mentioned before how total number of calls can be misleading. In this program, we have a lot of calls to the random number generators at startup, which means our total calls analysis is thrown off. What I'm going to do is run a number of calls analysis on a slightly different version of the program. Here I'm taking the startup part of the program and running it before we start gathering our statistics. This is one of the ways cProfile is powerful. You can use it to gather statistics on the whole program or only on one specific aspect of it. Now, when I run the program and generate a report, the number of calls report is not cluttered with irrelevant details. We can see here that the total number of calls is actually pretty low, so it isn't the number of calls that's the issue. It's that we have a few calls that each take a long time. Now let's have a look at the statistics generated by the fast version of the same program. The slow calls have been replaced with rewritten equivalents in Cython, which turns Python into C for accelerated performance. I did another video about this earlier, and I've linked that below. As you can see in the report, the generation and render functions are still there, but they have braces that indicate they're external calls rather than Python native. And the total time per call is now so low, it barely even registers in the per call column. All of the other functions above it also have very small per call time, so it's safe to assume this program is as optimized as it gets for now. If you like this video, be sure to leave a comment below. Don't forget to subscribe to our YouTube channel, and for more tech tips, be sure to follow us on Facebook, YouTube, and Infoworld.com.